Today we're going to explore the equation of a circle. So here we're given a circle here with the center at 0, 0. We want to find the measure of AB in terms of x and the measure of CB in terms of y, and then write a Pythagorean relationship for the sides of the triangle. So we have a radius here of 1, and this point here, C, is at x comma y. So if I'm looking at point B, that would be at point x comma 0. And then A would be at 0, 0. So if I want to think about the measurement of AB in terms of x, technically we're just going in the horizontal direction. We're going x units. But I'm going to not write it as just x, but I'm going to write it as x minus 0, because we ended at x and we started at 0. For CB, I'm going to do the same thing. We're going up from here to the top point. So we're going just up in the y direction, up y units. But just like we did with the x, I'm going to write it as y minus 0. So this side right here, x minus 0, and this side right here, y minus 0. We want to write a Pythagorean relationship for those sides. Well, again, we can just take the two sides squared, the legs, add them up, and that should give us the hypotenuse squared. So x minus 0 squared plus y minus 0 squared equals 1 squared. So x minus 0 squared plus y minus 0 squared equals 1. And so that's our Pythagorean relationship. We're going to skip this next one. I want to actually get to this guy right here. I think this is a good problem. We know that the center here is at 3, 1. And we know that this point B is at x, 1. And then y is at x, y. So if we want to find AB, let's see. So we're going to find the difference in the x's here. So x and 3 is x minus 3. And for the y's, it'd be y minus 1. And so the Pythagorean relationship is x minus 3 squared, that's the side here, and then the side here is y minus 1, equals the hypotenuse squared, which in this case is 1. And again, we can just leave that as 1. So hopefully we're getting to the idea of, if we have these points, they can be anything. We can call it H and K. This point here has to be at x comma k. If we wanted to find the distance in the x's, we would take x minus h. The difference in the y's would be y minus k. And then we have our radius. So our relationship here is x minus h squared plus y minus k squared equals r squared. And so that is the general equation we're going to use for a circle. And that's called center radius form. And what we're going to do now is just basically take some things, plug them in. This should go fairly quick, and then we'll get into some more complicated stuff. But notice here when we have the x minus h, we're changing the sign of the center of both the x and the y coordinate. And the radius is just that number squared. So as an example, number 1, when I plug in 3 and negative 6, it would be x minus 3 squared plus y plus 6 squared equals 6 squared, which is just 36. And in a problem like 4, this is where it gets a little tricky because the radius is not a whole number. Technically, we're going to write it as x minus 0 squared plus y minus 0 squared equals 3 root 5 squared. This is where we've got to be careful when we square that 3 root 5. It's both parts being squared. So 3 squared is 9. And then root 5 squared is just 5. So 9 times 5 would give me 45. And then here, I don't need to leave it as x minus 0. I can if I want to, but I can write it as x squared plus y squared. We want to get in the habit of recognizing that x squared plus y squared means the center is at 0, 0. Now what we're going to do is take these and expand them out so that we can put them in what's called general form. So we're taking it from center radius form and turning it into this general form where everything's over on the one side and we have 0 on the other. So essentially we're going to expand this guy out. So let's take this here, x minus 3 squared. So I'm going to use the area model to expand that out. So x squared, negative 3x, oops, disappeared on us, and then this is a 9. I'm going to do the same thing with the y's. So y plus 6, y and 6, so that's y squared, 6y, 6y, and 36. So what I want to do then is I want to put that all together. So to do this, I'm going to start looking for my like terms. I have 1x squared, and then my next thing I'm looking for is a y squared. I have one of those. And I have negative 3x, and negative 3x is negative 6x. And then I have a 6y and a 6y, which is going to give me a 12y. The next thing I have here is the 9 and 36, which together is going to give me 45. So I'm going to go ahead and write that. And I don't quite have it in general form because I still have that number on the other side. So I'm going to bring that 36 over to the left side, giving me x squared plus y squared minus 6x plus 12y plus 9 equals 0. And now it's in general form for a circle. So what happens if we want to go from general form to center radius? That's going to be a little bit more challenging to do. All right, so let's take a look at what we have on this problem here, number 1. So what I want to do is something called completing the square. And to complete the square, it's going to make things a little bit easier for me. I'm going to do it in 2 shots. I've got the x and then the y. So I'm going to take my x part and complete the square there. And like I did before, I'm going to use the area model to do this, because again, I just like the way it's organized, so I keep apologizing for it, but I really like the area model. So we have x squared, we have an x and an x. The middle term has to be a 10x, and in order to have a completed square, something where we have a quantity squared, that means that these two are going to have to be the same. They're the same factors. And what then happens is that these two boxes are going to end up having the same number and have to add up to 10x. So they must be a 5x and a 5x. That gives me a 5 and a 5, which then means I have to put a 25 into the problem that wasn't there. And so when I do that, when I put a 25 here, that will tell me what number completes the square. I'm going to put it here and also on the other side to balance that out. I'm then going to take the same thing for the y's. So I've got my y squared term. This guy right here. So that's a y and a y. These two boxes are the same and add up to negative 6. So that's a negative 3y and a negative 3y. So negative 3 and negative 3 gives me 9. So this puts a 9 there. You add a 9 to the left, you have to add a 9 to the right. Now the nice thing about setting up the area model is that the next step is to factor, and we've already done it. We've already taken that step kind of out of the works here. So I'm going to take this x quantity, it's x plus 5 squared, and I'm going to do the same thing with the y's. So plus y minus 3 squared, and put these together. So 32 and 25 is 57, and then add 9 more, which will give me 66. And so I'm done with the problem now because I've completed the square for the x and for the y, factored it, and then made sure that I balanced everything out on the other side. So that's how you're going to turn from general form to center radius form.